So we've talked about redundancy, and that brought us into the fact that what I need to do when I build in redundancy is I need to create multiple links. And when we looked at redundancy, we looked at it in terms of having having multiple switches that were connected here. So if I were to go ahead and bring in another switch and say, okay, well, maybe I want um, maybe I want to have three switches here. And now this, if these switches were all connected, what do we have? We have a routing loop. So just like in this picture here, one of the ports gets blocked. Well, we didn't really discuss having multiple links between a single switch. And that's another form of redundancy. It's not that we're creating redundancy on the device, we're creating redundancy on the cable. But spanning tree protocol, and the way it works, it is always going to do the very same thing. It's going to block ports. And so that's what we're showing in this particular diagram here. Is spanning tree protocol is working properly when we use redundant links between switches. These two ports get blocked. Now, these are multi-layer switches that are right here, but they don't have to be. They could just as easily be any other switch that we wanted. And so this idea of redundancy works fine. If I just want to duplicate this link, then I have redundancy, and it's sitting there. If I decide to come through and happen to cut one of these wires, but miraculously the other wire is untouched, then that redundancy comes into play, and the port gets unblocked, and we have a wonderful backup cable, right? But when you think about it from a realistic standpoint, right, if we have multiple cables that are running it down a raceway or conduit or something, and we're trying to protect against that, the only thing that we're really protecting against is a connector going bad. If we're trying to protect against the cable getting sheared, that's not really gonna redundancy here is not really gonna solve that problem, right? So if that thing gets sheared, chances are the whole thing's gonna go down. But anyway, what we really need is, while this is a great solution for simple redundancy, what it doesn't do is allow us to actually utilize both ports. And so that's where we have another need for another program running on the switch to allow us to utilize multiple ports. And that's where we have what's called Etherchannel. Now, Etherchannel is a brand. It's just like a product that Cisco created. Another word for it is bonding. When I take two connections and I utilize both of them to send the traffic, I'm bonding, right? So that's and I can bond at multiple layers. In this particular case, when I bond at layer 2, I'm using Etherchannel. So I do have the ability to do bonding on a non-Cisco switch, and that's, instead of Etherchannel, it uses an open source protocol called Link Aggregation Control Protocol, LACP. Right? That's for a non-Cisco device. So that allows me the ability to utilize link aggregation between non-Cisco and Cisco devices. So if I want to use my Aruba switch or my Palo Alto switch and connect and communicate and connect these devices together and utilize them, I can absolutely do that. And so it does work a little bit differently, but where I see the need to do this is is not necessarily in local networks, but it is in carrier class networks where I have maybe what would be called a carrier hotel, I'll give you a picture of that. If we look up carrier hotel, this is a co-located space, and this is we're going to look at something like that. If it's a co-located space in a building, it could be a large knock, right, or some other facility like this where I might have a cage for AT&T, and I might have a cage for Level 3, and I might have a cage for Verizon and some other provider, and we have to get these switches to be connected to each other, right? And so there's a physical connection there that has to be made in that carrier hotel because I have to be able to offload the data between networks, right? And so that's what happens here. And so many times I will need to actually go in and do something like this in a carrier environment, right? And so that's where LHCP comes in because one company may use Cisco switches, another company may use something altogether different, right, for their high-speed networks. But so when we bond, we do have limits. But what happens in many modern networks now is we can still bond ports, but the overall throughput of the different ports have increased dramatically. I can use long haul or short haul fiber to get speeds of up to 40 or more megabits. I'm sorry, gigabits through the link. So I mean the amount of speed is dramatic. But at the time when this particular protocol was invented, we didn't have that. We only had maybe 100 meg or even a 10 meg port. And so I had to be able to utilize the same equipment and just basically daisy chain ports together. Right? And so that's what happens here. So this is kind of what that looks like. This is our idea of this switch. And I can use, I notice this does say I can use a gigabit ports, right? So in this case, I've got 6 ports right here, right, that are in a group. 4 right here that are in a group, and I'm binding these together, right? And so that just allows me, what I get to do is I get to control how many ports on the actual switch that I can link together. So it gives me a lot of flexibility. Notice that it says currently each Ether channel can connect up to 8 compatibly configured Ethernet ports. So what does that mean? That means if I use a gigabit port, I could have 8 gigabits of throughput on that one Ether channel. If I had a 10 gigabit port, I could have 800 gigabits, right? That would be a pretty expensive switch, obviously. But it gives me some flexibility in how I create a network. So my switch doesn't actually just become something to access the network with. Now it becomes something to link the network with in the high speed area, right? So I'm growing this thing, and I'm putting a head on it, right? So I'm actually able to grow this network and make it larger. And that's what this does. So PAGP, port aggregation protocol, right, allows me to actually go ahead and aggregate those ports. PAGP is Cisco proprietary. And this is the actual protocol that will create those Etherchannel links. And it's kind of interesting that I would create this Etherchannel and then have to create some other protocol that would implement it. But that is again, that's Cisco for you, right? The engineers had to figure out, okay, now that I want to make this thing, and that's fine, how do I actually allow it to communicate? They had to create a protocol. Why they didn't call it Etherchannel Protocol, I don't know. But they didn't, and it was more than likely they utilized an old protocol. But one thing to know about this Etherchannel is if the ports do not have that same speed and duplex and VLAN information, right? So if I have a VLAN mismatch across my switch, my Ether channel is not going to form. If I have a port that goes out, if I have, let's say I have 8 ports that are all created into an Ether channel link, and one of those ports gets damaged, that is going to ruin that Ether channel. It will not form, right? So I will not be able to use it in that way. I will be back to my original configuration on that port. Probably a trunk link, right? But so I can actually use the same type of logic that I use with my dynamic trunking protocol. We have auto mode and we have desirable mode. So remember, auto is listening. That's where we get the passive negotiating state. Desirable is active state. So at that point, I am always using the protocol to create a PAGP packet and bring that Ether channel up. That's what I want to do. And so if all the conditions are met between both ends and we're in the PAGP desirable state, then we can bring that Ether channel up and be able to use it. And if I do it in on, basically they don't exchange any PAGP packets. They're both in ignore state, but they assume that the other side is up. All right, so that's a little bit dangerous in that particular case. But if I know how all the switches are configured, I should be able to confirm that the Ether channel link comes up and it actually works. So we're going to look really quickly at how to set that. This is a very similar to our dynamic trunking protocol. When we have switch 2 on desirable auto, and that one's on, I'm not going to get a channel establishment because it's not going to meet the requirements, right? It's not going to bring it up. When I put it in that active mode of desirable, yeah, there comes the channel. I'm going to establish it. And then if it's if either one of these are true, if that desirable is true on either switch, that channel comes up. And then auto, right? That's basically puts it in passive mode. Nothing's going to happen. So if you got that one switch in passive mode, it's not going to do anything, right? Even if that one's on. Right? That's why. And LACP is part of the 802.IEEE specification, right? So it's going to work very similar to that. If one is in active mode, we're going to get the LACP conglomerate to come up. If they're both in active mode, it comes on. If they're both on, it comes on. But remember, just because I turn it on both sides doesn't mean there's communication. Only when they're both active or one is active is there actual communication between the two devices to establish the link. And that's pretty much it. When we do that, we have a Ether channel that gets established, and we can look at it and we can see it.